Welcome to Ask and Learn.
Hello everyone. In this problem, a AC bridge is given which have the value of resistance R1 equals to 400 ohm, resistance R2 equals to 600 ohm, resistance R3 equals to 1.2 kilo ohm, and the capacitance C2 will be 0.3 microfarad. Right? Now we have to find out the value of variable resistance or unknown resistance Rx and the capacitance Cx. We have to measure the value of these two parameters. Okay, so let's see what happens in case of AC bridge. The circuit is like that. The circuit is given like as there are 4 branches which have impedance Z1, Z2, Z3, Z4 and emitter G this, and the AC source let assume this is Z1, this is Z3, this is Zx and this is Z2. This is Z2. Assume here voltage V1, here voltage V2. So in the balance condition, there are no current flow through the meter or through the galvanometer. So hence we can say that at balance condition V1 equals to V2. We can say that at balance condition V1 equals to V2, or the parameter of this bridge is given by Z1 Zx equals to Z2 Z3, right? Where Z1 equals to R1, Z2 equals to R2 plus 1 upon j omega C2, Z3 equals to R3 and Z4 equals to, or we can say that Zx equals to Rx, Zx equals to Rx plus 1 upon j omega Cx. Okay, so now at balance condition what happened? Z1 into Zx equals to Z2 plus Z3. So by putting this value in the equation, what about the Z1? Z1 is R1, Z1 is R1 and Zx is Rx plus 1 upon j omega Cx equals to Z2 equals to R2 plus 1 upon j omega C2 and Z3 equals to R3. So we have to calculate the value of Zx. Then it is written as Rx plus 1 upon j omega Cx equals to R3 upon R1 R2 plus 1 upon j omega C2. Fine. So now by separating the real part and the imaginary part. First, if we separate the real part, then the equation will be right in the form of Rx equals to R3 upon R1 into R2. Then Rx equals to, put the value of R3, R1 and R2. It is simply 1200 upon 400 multiplied by 600. Then Rx will be 1.8 kilo ohm. It is clear? Again, if we separate the imaginary part, then the function will be 1 upon j omega cx equals to R3 upon R1 1 upon j omega c2. Now equating this function, the cx will be R1 upon R3 multiplied by C2. Now putting this value, Cx equals to R1 is 400, R3 is 1200 and C2 will be 0.3 into 10 ki power minus 6. Then the value of capacitance Cx will be 0.1 microfarad. It's clear? So in this problem, the value of resistance R1, R2 and R3 will be given, and we have to find out the value of unknown parameter Rx and Cx. So simply we have applied the balance condition. By putting this balance condition, assume Z1 equals to R1, Z2 equals to this function, Z3 and Z4, equating this function, and by separating real part and imaginary part, we just calculate the value of unknown parameter Rx and Cx. Thank you.